Okay, then we're going to get started uh, on a useful lesson here, graphing two variable inequalities. Seems like a tongue twister, and we're just getting started. I've kind of made you a little chart here to show you the difference between a one variable inequality and a two variable inequality. On the left side, x is less than positive 3. Well, if this is 0, here is going to be 3. Let me get a different color here. There's going to be 3, and the numbers that are less than 3 are all through here, and the arrow points there. On the right side, they look exactly the same, but because the problem tells you it's a two variable inequality, then you know that you have two variables here in your graph. You have an x-axis and you'll have a y-axis, and x is less than 3. We graph x equals 3, and for x equals 3, that would be a vertical line that crosses the x-axis at positive 3. And remember, in this case, since it is just less than, then we have we're going to have a dashed line. Less than and greater than will have a dashed line if it says less than or equal to, or greater than or equal to, it'll have a solid line. All right, so now we have all that dealt with. Which values are going to be less than 3? Well, if we look here, this is 2, that's 1, 0, -1. All those values are less than 3. And so we will shade to the left of that line, to the left of that dashed line. And it should look something like that. For the problem down here, this one says y is less than 2x minus 3. This is kind of in slope, well, actually, this is in slope-intercept form. Here's the y-intercept at -3. 1, 2, -3. We put our point. And 2x, slope is 2 over 1, up 2, to the right 1, to the right 1. There we go. It's going to be a dashed line. And I know your lines are going to look a lot straighter than that. For some odd reason, where my marker was going down is not where the marks were going. And we have to figure out, because this is an inequality, we have to figure out which line of which side of the line to shade. You just always pick a test point. It doesn't matter which point you pick. I'll probably always pick 0, 0 when I do the work because it's an easy number to work with. But if the line goes through 0, 0, you cannot use that point. So let me just go ahead and pick a number here. Let's pick that point right there and see if it is a solution to the inequality. That would be -1, 2, 3, 4. And what's that, 2? -4, 2. So is that a solution to this inequality? Y in that case is 2. X is -4. 2 times -4 is -8. And -8 minus 3 is -11. Is 2 less than -11? I don't believe it is. So then everything to the right or to the right below of the line is a solution. And what does that mean, is a solution? Let's pick this value right here, 10, 10. It's way down here in the corner, you see it? 10, 10. Y is 10, and X is also 10. 2 times 10 is 20, minus 3 is 17. Now let's look. Is 10 less than 17? Yes, it is. So this 10, 10 is a solution. And it doesn't matter which point you pick. You can pick any of these points that I'm marking, and they will always be solutions. And the first point that I picked down here was not 10, 10. It was actually 10, negative 10. So y was negative. And so that's still true. Negative 10 is less than 17. The first point I picked was actually up here. And you notice how it is still a solution. So basically all these points, and when you start putting them together, getting them real close, because you can pick a point here in between the grid lines, they start to look like you are shading. So that's kind of the shading takes the place of over here on one variable. This is all the shading we do. We shade one dimension, one variable. On the right side, we have two variables, x and y, so we should be shading like I've shown you. Pay attention, one variable or two variable, because sometimes they do look the same, but the graphs do not look the same. Here's a situation that you could use, that you may use in life someday. You're going to be you're going to be an office manager, and you are $45 allocated. I think those probably should have been switched around. As an office manager, you are allocated $45 in your budget to spend on fruit for your office each week. This week you are going to purchase grapes, using the variable G for that are $1 per pound, and apples that are $2 or $2.50 per pound. Write and graph an inequality to model the amounts of grapes and apples you can buy. Well, we know that grapes are $1 per pound, apples are $2.50 per pound, and whatever we spend on grapes and whatever we spend on apples, that amounts will be added together to figure out how much money we are spending on fruit for the week. Now, if we're allocated $45, well, let's think here. Are we allowed to spend more than $45, or are we allowed to spend less than $45? Well, if we're only allocated $45, we cannot spend more, so we're going to be spending less. The amount we spend on grapes and apples must be less than $45. Now you have to ask yourself, can it be equal to $45? Well, if we're allocated 45, we're allowed to spend all 45 of it. So that's why we are, the inequality says less than or equal to. Okay, so we've done this part. Right. Second part says graph. Well, let's go ahead and graph. I have let me get that out of the way for now. I have a graph here on the right side. Let's let apples be down here. And on the y-axis, we're going to put grapes. Well, if we think about this, if grapes is going to be y, we can subtract $2.50 from both sides, or we can subtract 2.5a from both sides, which that leaves us with the grapes is less than or equal to negative $2.50 times the amount of apples plus 45. And this leaves us with slope-intercept form now. Slope-intercept form, we should have the y-intercept and the slope. I think I want slope as a fraction. So 2.5 we know is 2 1/2. Change this to an improper fraction. Take the bottom number, the denominator 2, multiply it by the large 2, and 2 times 2 then is 4, and we add it to 1 to equal 5. And the denominator will stay the same, 5/2. So G, the grapes, are less than or equal to negative 5/2 A plus 45. So we're graphing this. We need to start at the y-intercept. Our graph doesn't go up to 45, so we're going to have to make some modifications here. Let's make, let's see, 10, 20. Let's make each one 5. So each interval up along the y-axis will be 5. And so our first point is placed right there at 45. Now, do you want the amount of apples to be 5 also? Apples are a little bit more expensive, so I don't think we have to make those going up by 5. We can make those going up by, oh, whatever you're interested in. We could probably make those go up by 1. And so now let's go ahead and graph some more points. We have the y-intercept placed, and now let's go ahead and graph negative 5 over 2. Well, negative 5 over 2, change in y is negative 5, so that means we go down 5, and means we go down 5, and we go to the right 2. Negative right here is why we're going down. But we have to look at our graph, though. We can't just go down 5 blocks, then over 2 blocks, because if we went down 5 blocks, let's say we went down 5, 1, 2, 3, 4, 5, that puts us right here at 20, and we went over 2, that would move us 2. And from 45 to 20, we know that's not 5. So we have to pay attention to our graph. Our intervals along the grapes axis, the y-axis, will go up by 5. So essentially, we just need to go down 1 space, and then along the apples go by 2. So there's 1, 2. So we've gone down 5 and to the right 2. Okay, now we're at 40, down 5 to 35, and to the right 2 to 4. Down 5 to 30, to the right to 6. And this is the path that we're going to be following. And we should be thinking, are we going to have a solid line or a dashed line? The inequality is less than or equal to, so it's going to be a solid line. I have a line right here for us. Let's go ahead and use it. That way we know it's going to be straight. So there you go. You have a solid line, and this is the solution to the problem, with the exception, which part of the graph do we shade? Well, if we're only allowed to spend $45, we cannot be spending money out here in this region, because that's going to be more than $45. So that's going to be everything here. And I am tracing the x and y axis for the simple fact that we can't have a negative amount of money in this example. When you do other problems that aren't real life, you will be able to go into negative numbers. So the solutions to this are everything in here that'll be shaded. And what does that mean? Well, that means if I wanted to buy 30 grapes or 30 pounds of grapes and 3 pounds of apples, I would be less than or equal to $45. If I wanted to buy 25 pounds of grapes and 8 pounds of apples, well, that would be equal to $45, which is allowed what I'm spending. It's equal to 45 because it's on the line. Or I could come out here, 10 pounds of grapes, 12 pounds of apples, and I would still be under the amount of money that I am budgeted to spend on apples and grapes. So this is one situation in which we will be using two variable inequalities in real life, and in order to use those in real life, you have to you have to know how to use them in this algebra class. This next example here says sketch the graph of the two variable inequality. And you notice it says two variable inequality. It shows us two variables, x and y. Well, let's go ahead and graph this. When we think about graphing that inequality, first we have to graph the line like that. X plus 2y is equal to 4. And then in order to graph the inequality, we just think, is it a solid line or a dashed line? And then which side of the line do we shade? Those are the two additional steps to graphing inequalities that you have to add to graphing a line. So x plus 2y is equal to 4. Let's go ahead and find our intercepts. We're going to let x be equal to 0, and then y be equal to 0, and we'll have our intercepts. So the first one says y is equal to 0, so x plus 2 times 0 is equal to 4. From now on, I won't be writing this part in there. I'll just go ahead and say it and leave it blank. So x is equal to 4 when y is equal to 0. The second part, x is equal to 0, so 2y must be equal to 4. Divide by 2, divide by 2. Y is equal to 2. So we graph those points. The first one, 4, 0. 1, 2, 3, 4, 0. The second one, 0, 2. Right there. Now we need to determine whether it's a solid line or a dashed line. It just says greater than. There is no equal to with it. So we have a dashed line. That's not what we wanted. Let me bring it to the front here. I think I'm going to get better at putting this line on the graph for you. Here we go. Okay, so we have the line graphed. Dashed line through those 2 points. Now we have to pick a point to plug into the inequality that will tell us whether that point is a solution to this inequality. Pick 4, 4, 4. I'm just randomly picking a number. X is 4. X is 4. Y is also 4. y is not 8. All right, let's try that again. Okay. All right, x is 4, y is 4. So this is going to give us 4 plus 8, which is 12. Is that greater than 4? Yes, 12 is greater than 4. Let's try this point right here, 0, 0. Plug 0 in for x, 0 in for y. Is that greater than 4? Well, 0 plus 0 is 0. Is 0 greater than 4? No, it's not. So 0, 0 is not a solution. We found out that 4, 4 was a solution. So it's everything above the line is a solution to the graph. 0, 0 is not. So we do not shade that side of the line. A few steps here to solve the problem. To graph this. This one says sketch the graph of the two-variable inequality. So we're looking there. Negative 2/3 x plus 1 is less than or equal to y. If you think about it, y is greater than or equal to negative 2/3 x plus 1. And this might remind you of slope-intercept form, y equals mx plus b. Y-intercept is at positive 1, and your slope is negative 2/3. That means we go down 2, to the right 3. Down 2, to the right 3. Or we could have went up 2 and to the left 3. The left would be the negative part. So let's look. Solid or dashed line, it says or equal to. So we are going to be using our solid line. And looking at this graph, now we need to pick a test point that the line does not go through. Let's pick the point 2, 3. So the point 2, 3. I'm going back to the original equation here. Or I'm sorry, the original inequality. Negative 2/3. There's a long pause there because I don't want to use 2, 3 as our test point. Because I have a fraction of 2/3, I want to pick a number that's going to help get rid of that fraction. So I'm going to pick the denominator to be the x. So let's pick 3, what is that, 3, 4? Now, if x is 3, y is 4. So now let's work this out. Negative 2/3 times 3, well, 3 over 1, and I know the 3's will cancel out, so I'm left with negative 2. And you notice that's the reason why I picked 3, an x value of 3, so that way it would cancel out with the denominator there. So negative 2 plus 1 is less than or equal to 4. Negative 2 plus 1 will give us negative 1. And is that less than or equal to 4? I guess I probably should have put the question mark here. Negative 1 less than or equal to 4? Yes, it is. So this point of 3, 4 is a solution to our inequality. So we will shade everything above the line. Let's look here at this one. It says sketch the graph of the two-variable inequality. Well, if we were to think about this as y plus 3 is equal to 0.5, I'm going to go ahead and write that as a fraction because I'm not a big fan of having decimals for your slope. And if we're looking here in blue, we have a point slope, a linear equation in point slope form. So we know m is equal to 1/2, and the point that is given to us, well, there's the x, and here's the y. Remember, it should say y minus y sub 1. So since it says y plus, that means y sub 1 is -3. And so from here, we graph the equation. We start out at the point 5, -3. 1, 2, 3, 4, 5, and down 3. You put a point. The slope of 1/2 means you go up 1, to the right 2, up 1, to the right 2, or you could have went down 1 and to the left 2. It says greater than, so that will be a dashed line. It's a dashed line. And now we need to figure out which side of the line we're going to be shading. Like I said a few slides ago, 0, 0 is going to be the line that we're going to that I typically always choose. So let's go ahead and plug that into the original inequality up here. We're going to plug 0, 0 in there. Y is 0. X is 0. And 0 plus 3 is 3. 0 minus 5 is -5. And so 0.5 times -5 will give us a -2.5. So if we look, 3 is greater than -2.5. Is 3 greater than -2.5? Yes, it is. So then this side of the graph is a solution to the inequality. So any point above the dashed line will be a solution to the inequality. Let me see you go ahead and sketch a graph of this, and see if you can pick a point and see which side of the line you'll be shading. You can pause the video and I'll work this out in one moment for you. We know that if we look there, 3x minus 5y is greater than or equal to -15. Well, that's going to be in standard form. We put an equal sign there. So if we let x equal 0, what's the value of y? Well, 3 times 0 is 0, so we're left with -5y is equal to -15. Divided by -5, y is equal to 3. Now, we're going to let y be equal to 0 and solve for x. So 3x minus 5 times 0, 5 times y, is going to be, that's 0. So 3x is equal to -15. Divide both sides by 3. X is equal to -5. -5. So we graph those 2 points. 0, 3 means we go left and right 0 and up 3. -5, 0 means we go left to -5 and up and down 0. Solid or dashed line? What type of line is that? That'll be a solid line. So we have our line graphed. And now let's pick a point. Let's pick a point. 0, 0 is a good one to pick. 3 times 0 minus 5 times 0 is greater than or equal to negative 15. Is that true? Well, we know we have 0 minus 0, which is 0. And 0 is greater than or equal to negative 15. Is that true? 0 is not greater than or equal to negative 15. So this point of 0, 0 is not a solution. So we have to shade not this side of the line, because 0, 0 is not a solution. We will shade the other side of the line. Well, one time this man, he went to work for a veterinarian at the zoo, and the veterinarian told this man, he said, look in the lion's mouth. And the man asked, well, how do I do that? And the veterinarian looked at him and said, you do that very carefully. Very carefully, you look into the lion's mouth. One more here. Go ahead and graph this and figure out. Pause the video. You can check your graph after I'm done, or after you're done. All right, I'm looking up here. I'm graphing. Here's the y-intercept at negative 6. 1, 2, 3, 4, 5, 6. The slope of 1/4 means you go up 1, to the right 4, up 1, to the right 4. You could have also, from the very first point, you could have went down 1 and to the left 4, because down is negative and to the left is negative. So negative 1 over negative 4 is equal to a positive 1/4, and that's our slope. Let's look. Solid or a dashed line. We have a solid line. And which point of the line are we going to be shading? I'm just going to pick, I'm going to pick 4. 4. Let's pick 4, 1. 4, 1. Plug it in. Y would be 1. X is 4. We know the 4's cancel out. So we have 1 minus 6, which is negative 5. Is 1 less than or equal to negative 5? No, it is not. So the point 4, 1 is not a solution to the equation, not a solution to the inequality. So we will be shading everything on the other side of the line than that point 4, 1, and the other side of the line would be right here. Everything down below it. This one right here, you only have one variable in the inequality, but you have to read your directions. Sketch the graph of the 2 variable inequality. So this right here can be rewritten as 0x minus 2y is less than or equal to 10. And we know 0 times x is 0. So that's the reason why we just have negative 2y is less than or equal to 10. So let's look here. We have, let's graph negative 2y is equal to 10. Well, you have to get y by itself. y is equal to -5. So we have to graph that line of -5, or y equals -5. 1, 2, 3, 4, 5. It'll cross through there. Is it going to be a solid or a dashed line? Solid or dashed line? Solid. And we know that if it's y equals 2, it's going to be a horizontal line crossing the y-axis at -5. Pick a point. Pick the point 0, 0, and plug it in for y. Actually, you plug it in for x and y, but there's no x, so we just only plug it in for y. It says -2y is less than or equal to 10. 0 is less than or equal to 10. That is true. So the point 0, 0 is a solution. And so we shade everything above the line. Key point here, you had to pay attention to it being two variable inequality and graphing it on a coordinate plane like this, where sometimes that these inequalities right here look like they have one variable in them, but 0 times x eliminates that x variable. Let's see, you go ahead and graph this one here. It says sketch the graph of a two variable inequality, and we know that it only has one variable in it, so it's going to be I don't know what it's going to be. I know what it's going to be. I'm going to tell you in 1 second. So you go ahead and try and do this on your own, and then I'll check the graph, or you check your work here in 1 second. Okay, x plus 2 is less than 7, so what should you do? You need to get x by itself, so you say x is less than 5. And you're going to graph x is equal to 5. That's what your graph is going to look like. So we know it crosses at +5. The graph will cross the x-axis at +5. Is it a solid or a dashed line? It just says less than, so that means that it's a dashed line that crosses the x-axis at +5. Vertical line crosses the x-axis at +5. I'll pick a value for x and y. Pick 0, 0. Plug 0 in for x. And 0 plus 2 is 2. Is 2 less than 7? 2 less than 7? Yes, yes, yes it is. So, since 2 is less than 7, we know 0, 0 is a solution. So you shade everything on that side of the line. And that'll be the last slide we have for today. Graphing two variable inequalities. Just the important part, make sure you know how to graph a line, and then that'll help you out with graphing two variable inequalities.